Okay, so here we have the following situation. Here's a wall right there, and it's 100 feet tall, and I'm standing here and I'm looking and see the angle of elevation from my eyesight to the ceiling, and that's 18 degrees. And from my eyesight to the bottom of the wall, it's 3 degrees. So this is 3, and this is 18 degrees. So we want to determine the distance between where I'm standing and the wall. Any suggestions on how to proceed? We had something similar a while back, but you may not remember, which is okay. There are 2 right triangles here. I will denote this piece by A and this piece by B, so then A plus B equals 100. And in the top triangle, give me, please, a trig function that involves this piece and x. X is the distance between this place I'm standing and the wall. 10. Say it again? Yeah. 10. So you will write that tangent 18 degrees equals
A over x.
Excellent. Thank you. Tangent 18 degrees is A over x. The same thing for the second triangle, please.
So tan 3 equals B over x.
From here, we'll solve for A. If you look back in your notes, you will see a problem like this. And we solve for B, which is x tangent 3 degrees. And all you have to do is just put them in this equation. So we will put x tangent 18 plus x tangent 3 equals 100. Any suggestions how to proceed now? Excellent. We factor out x, tangent 18 plus tangent 3, and we divide. Please give me this and make sure that your mode is in. Yes, please. So give me the answer. How much? Oh, okay. I thought I can rely on you. Divided by, in parentheses, tangent 18 plus tangent 3. Okay. I got 265.02. And the measurement unit, I didn't read the measurement unit. Is it feet?
Yes.
Feet it is. Any questions about this problem? Any questions? Is everyone okay with this one?
I tried to write that, but it came up as wrong.
I have to take a look at what you wrote, so I can say. Okay, so here's the second question. We are told that sine t equals x over x plus 5, which means there is an acute angle in a right triangle, t, whose sine is x over x plus 5, which gives us this leg as being the square root of x plus 5 squared minus x squared. So are we okay so far? So the opposite over the hypotenuse. And now I wrote the Pythagorean theorem, and I determined the leg that is unknown as x plus 5 squared minus x squared. Is this okay? Everyone? Yes? Mm-hmm. Okay, so now I have to expand this and simplify it as much as possible. So this is x squared plus 10x plus 25 and minus x squared. So the answer is 10x plus 25. So now we have we have all the sides of this triangle, and we're asked to tangent inverse of x over the square root of 10x plus 25 is obviously an angle, which means the tangent alpha is x over the square root of 10x plus 25. But it means that this is nothing else but angle t, because tangent is the opposite over the adjacent, which is this. So this cannot be anything else but t.
So that's the answer?
Okay, here's the third question. Any questions on this problem? Any questions? Okay, so now let's read the next one. Problem number 3. So this was 2. Here it is, here it is, here it is. Here it is. Okay, question number 3. Ready? Yes? Okay. Deja? Okay. Yes?
Oh,
Yes? Okay, perfect. So number 3, we have a parallelogram that has sides of length 17 and 10. (17 and 10) units. The shorter diagonal, this, is 13 units. Find the measure of the longer diagonal. So this is our question. So we want to determine x. Round your answer to 1 decimal place. Okay, so let's see how we address this. So for now, I'm going to copy it one more time. So we know that this is 17, we know that this is 10, and we know that this piece is 13. Okay. I'm just thinking right now. I'll explain in a moment, I'm just thinking about it. So this is 10, this must be 17, this is 10, this is 13. This, so the question is this. That's what we want to determine. Do we know anything about the, okay. Okay. So I basically want to determine the hypotenuse of this triangle. I know that this piece is 17. Okay. What else do I know? I know that this piece is 17. I know that this is 10. Okay, this is 10. And how do I involve the 13? Because 13 is also doing some... Okay. So I'm going to call this Y. I'm going to call this A and this B. I know that A plus B is 13. I know that y squared plus b squared equals 100. I'm just collecting information at this point. So this is still y. So y squared equals x squared plus 17 plus b squared. Okay. If you have any suggestions, shoot. If you see something I don't. So 13, okay, I see. So 13 squared equals a squared plus y squared. Okay. So I have a, b, x, and y, and I have 4 equations. Okay, so let's give it a shot now. So one more time, let me just talk about what I just did. And maybe I should start from scratch to explain. Okay, I haven't gotten anywhere yet. I have not solved the system yet, but I do have 1, 2, 3, 4 equations, and I have 4 variables. So I should be able to moving forward, but we'll see. So what I did was, so we are told that the longest side is 17, the shortest side is 10, and we are told that the shortest diagonal, which is this, is x. 13. So I tried to form some right triangles, and I did form one, which is this, and I denoted this piece, so this is 17, so I denoted this piece by A from here till here, this. Then I formed another right triangle, and I called this piece B and this one Y. And this is another right triangle. In this tiny right triangle, I can write that 100 squared equals b squared plus y squared. And this is what I came up with the first equation. Then I know that a plus b must equal 17. It's this. So this is my second equation. Then, remember, I'm trying to find this. So I formed another right triangle in which I have definitely 17 plus b, one leg, the other leg y, and the hypotenuse x squared. So this is where the third equation is coming from. And also from this triangle, I have that 13 squared equals a squared plus y squared. This is also y. So I have 4 equations, and I should be able to solve for all unknowns. Now the question is, where do we start? So let's see. What do I want to get rid of? I'm only interested in x. I don't care for a, b, y. So I'm interested in x. I only have one equation with x. So I will say that this is x squared equals y squared minus 17 plus b squared. Okay. So how do I get rid of y squared? Y squared equals 169 minus a squared, and also y squared is 100 minus b squared. Okay. So now from these 2 equations, I may have to solve for a and b first. So I'll set these 2 equal to each other and then solve for a and b. And let's see, the next step. So I have that 169 minus a squared equals 100 minus b squared. And from here, I say one or the other, it doesn't matter, 17 minus b. From this system, when I'm done, I should get a and b. So I will use substitution, and I will replace a by 17 minus b, perform the operation, and see what I get. I hope I'm not going around in circles. We'll see in a moment. So I'll subtract 169. So 69 minus 17 minus b, everything squared, plus b squared equals 0. So I moved to 100 to the left, and I got 69. And I moved b squared, negative b squared to the left, and I replaced a by 17 minus b, everything squared. Okay, so let's give it a shot. It's a nice problem. I just don't want to spend too much time on it, though, because I have a big plan for you to review. Okay, so b squared minus b squared. So b squared, this will be minus 17 squared and plus 34b, and minus b squared and plus 69 equals 0.
Sorry, which 2 equations did you just combine?
The 2 with a and b. I only have 2 equations with a and b. So I move on 100 to the other side, 169 minus 169. I replace a squared by what it equals to on squared, and negative b squared to the other side, positive b squared. Is that okay?
Okay.
I'd like you to check. If you think there is something, I'll rather go back and check. So 17, this is minus, this is plus, 2 times the first times the second, plus the second term squared with minus, and wonderful, wonderful, wonderful. So 34b equals 17 squared minus 69. Can anyone give me b? Okay, never mind. You're not cooperating today. 17 squared minus 69, and everything divided by 34. Let's see. Okay, it's not a nice number. So I may have to keep it as a fraction. So 79, what is 17 squared? We can always go back and check, of course, everything. I don't expect nice answers because it says round your answer to 1 decimal place. So, but I just wanted to see what this is. So this is 220 divided by 34. I prefer that as a fraction for now. I don't want to introduce too much error. So I got that b equals 220 over 34, or b equals 110 over 17. Okay, I have a then. 17 minus 110 over 17. So how much is 17 squared minus 110 then? Help. Minus 110. Okay, I got 179. So then a is 179 over 17. Okay, I'm back to my other equations. Am I done? Yeah, I'm done. So I will replace y. I will determine, I have b. I have to determine y from either one and then plug it in here. Is that good enough? Yes, please, Vanessa.
So going back to my question that
Yes.
I had, I plugged it in and it said it's wrong.
Which one?
The one where you did the triangle.
It cannot be wrong. What did you put in? I mean, this is a specific type of question that we can address at the end of the class. I mean, I don't think we should take the time. Right.
I don't know where I'm looking.
We can email each other. We can take a look at it again. I just don't want to spend the time on this right now. So maybe you have just half a minute at the end of the class. So, Sarmad, is this good enough? So once we determine a and b, so you can determine y from either one, and I would basically check, put in a squared here, b squared, and make sure I get y. And once I have y and I have b, I take the square root to get x. Is that okay? Yes? Good. So coming back to this equation, it cannot be wrong. There is nothing. Are we asked to...
Not that one, the other one.
What's this? So what did you plug in?
Exactly that.
Like what?
Right at the end. X over square root.
Well, I said t.
T.
I said t. I didn't say x over this. So, okay. Good. Next question for me. Anything else you have? Is there anything else? Yes, please, Bailey. Sarmad, is that okay? Good enough? Yeah, it's kind of...
Yeah, this kind of question won't come in the test, all right?
It'll take you 15 minutes, 20 minutes just to get it started. I'm not testing endurance. I'm testing... Yes. Yes, Bailey?
So it's from 8.1.
Yes?
So on a graph,
Yes?
f of x equals 4 cosine parentheses 4, and then there's like another parentheses x plus pi over 8 parentheses minus 2.
Like this?
Yeah.
Okay. So if we want to graph such a function, first of all, we have to determine the amplitude, we have to determine the period, we have to determine the phase shift, we have to determine the minimum, the maximum, domain range, and so on and so forth. Okay. So the amplitude is 4. I should write normally this, to be exact. Then we know that the maximum, let's determine the maximum and the minimum. Thank you for shutting that door. Imran. Okay, so what is the maximum and the minimum possible for cosine? So for cosine, minimum is -1 and maximum is 1. But we have to multiply by 4, right? So it's going to be -4 and +4. But now everything goes down 2. From -4 to +4, everything goes down 2. So it's from -6 to +2. So -6, +2. So I determine the range right away. Then we have to determine the period. And the period is always 2 pi for cosine, but it has to be divided by the number that multiplies x. So the period will be pi/2. The phase shift is b, which is this, but since it's going to the left, we have to write -pi/8. So we determine max, minimum, min. Domain, of course, it's all real numbers. And range, we have it. So now we know what to do. So where do we present the graph and how? Okay, what is pi/8? Pi/8 is half of pi/4.
Can you do it exact?
I'm sorry?
Can you do it exact?
That's what I'm trying to do. I can't otherwise. I don't know how to do this otherwise. So the period is pi/2. So pi/2 pi. 3 pi/2, 2 pi, -pi/2, -pi. This will be half, but I have to, this is 45, -45, but I have to start at -pi/8, which is half of this. The top maximum is 2. So 1, 2, 3, 4, 5, 6, and 1, 2. So between 2 and -6, so this is 8 half, it will be 4. So here is, this is not needed, but it will help me graph the function cosine. So remember, cosine looks like this, like a vase, right? So it has, since there is no reflection, if there is a reflection, then it will look like this. But there's no reflection. We don't multiply it by -1 outside. So it looks like this. It's just shifted to the left and stretched. Shifted to your, yes, left and stretched. Okay, so the maximum point is right here. And it has to do something like this. But with a period of pi/2, so I have to be careful where I start and where I end. So obviously it starts right here at pi/4. So pi/4 and another pi/4 will give us pi/2. So it doesn't even go anywhere, actually. So it will just do this. I don't know where it crosses. I have not determined that. So all it has to do is this. Ah! I'm sorry, I have to go this way. That's it. So now we can illustrate this with a graphing calculator. So this is 4 cosine 4 x plus pi/8 minus 2. So let's punch it in y equals 4 cosine, oh, careful. I want to go back to radians. Okay, so we have 4 cosine 4 again, parentheses, x plus pi/8 . So pi/8. Yeah, but I just realized when I was typing it in, I don't have a pi/2 yet. So this is pi/8, this is pi/8, this is pi/8, and this is, I need 4 pi/8s. So I made an error. I'm going to erase that. I have to have between pi over 8, 1, 2, 3, 4 pi over 8. 4 pi over 8 is pi over 2. And I don't have 4 pi over 8 yet. So in the middle, it's right here. Okay. I have to have pi over 4. So I need pi over 2. So I need 4 pi over 8. When I was typing it in, I just realized that I did not go all the way to pi over 4.
So the point on the left side is pi over 2.
So, no. Let me see. 1, 2, 3, 4. No. It's 3 pi over 8. This point here is 3 pi over 8 comma 2. This point here is negative pi over 8 comma 2. This point here is right in the middle. It has to have negative 6, and it has pi over 8. No, it has pi over 8. Okay, and then minus 2. I'm back. Okay, so now minus 2. I don't have enough parentheses. Careful. Minus 2. So 4 pi over x plus pi over 8 minus 2. And now let's go to the viewing window. The viewing window has to be between negative pi over 8 and 3 pi over 8 with a scale of pi over 8. And I want the minimum, since I know it's negative 6, I'm going to say negative 8. And I want the maximum, I know it's 2, I'm going to say 4. And when I click enter, I should see one complete cosine, nothing else. No other pieces. So I have to see this. And it starts at this point, at pi over 8, comma 1, and it ends at 3 pi over 8 because I have 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, which is exactly the period of pi over 2. Bailey, is this okay?
Yeah, I was just kind of confused on how you find like the exact maximum and minimum. We can solve that algebraically.
Is that clear?
Yeah, that's
So
clear.
remember, cosine is between negative 1 and 1. When you multiply by 4,
Yeah, I got how you got like the y values, but how would I be able to find like the exact x values? Would that be possible?
yes, we found the exact x values because we know it's a left shift of pi over 8. So I know it's pi over 8, 1, and it's 3 pi over 8, 1, and I know that this has to be right in the middle. It's a symmetric graph. So right in the middle, this must be pi over 4, this must be pi over 4, and this is negative 6.
So, okay. So you just have to.
Yeah, these graphs require some routine and some, yeah, they're not friendly. To be exact, because we did not, I only showed a couple of problems in this one, I did not ask you to graph it on the test. What I asked you to do is determine the max, min, and determine the period and phase shift, but I didn't ask you to come up with a graph. It's time consuming, and it's not really a big deal.
Okay, I was gonna ask, like, if we were to graph, you like squish everything in between pi over 2 and pi 3 pi over 2. That
Say
kind
it
of,
again?
like, okay, so you like intervals are like pi over 2, pi, 3 pi over 2, and then 2 pi. You squish everything in between them, so you don't give exact like interval numbers. That's why I have difficulty graphing.
But I do. Of course I do. So I present where pi over 2 is and negative pi over 2 is there. These are always the markers, yeah. Right? I always do that. Otherwise, you will not be able to find the points. So if you don't show negative pi over 2, negative pi, pi over 2 pi, and so on and so forth, you're not going to be able to graph.
You can still do it. You times the period by 1 over 4 to get how much.
But you still have to show the points on the graph. You cannot just see this is the point and you don't know where it is. You can't graph that way. It's not right.
So
I'm sorry, Imran.
can we add pi/2 with period and then divide by 4 and then plot the interval.
Yeah, that's possible too. Yeah. Okay, can we start reviewing?
Yes.
Anything else? Do we have, is that okay?
So I'm not clear about how to find the interval.
How to find what?
Like, you know, the interval, the max point and the min point.
Yes?
Yeah.
Okay, so you know that cosine is between -1 and 1?
Mhm.
If you multiply those numbers by 4, you have -4 to 4.
Okay.
Let's do this. Any cosine of an angle is between -1 and 1. Any angle, right? If I multiply all three sides by -4, do I get this? If I subtract 2 from all three sides, do I get this?
Why we are doing this?
Because you want to find the maximum and the minimum.
Okay.
So here's your minimum, and here's your maximum for this function. This is between -1 and 1. I multiplied all three sides by 4, and I subtracted 2 from all three sides to find the minimum and the maximum. Minimum -6, maximum 2.
So is this our x point or y point?
If we talk about max or min of a function, we are not talking about x. It's the function with the minimum and the maximum. We're not talking about minimum and maximum. We're talking about minimum and maximum. It's always the y values.
Because the double sign there are they need 2 points, x and y. But they are
Right. So once you determine, yes, of course. So once you determine the points, then this is pi -5 and 4, 1. Yeah, you will have to determine x and y, but this is the maximum. And this is the minimum. Not maximum and minimum.
So on the test, you give us a graph.
Hold on one second. Is that clear?
okay.
I mean, we can talk about it at the end of the class if you like. Is that okay? Is that what your question was?
Yeah, I got it. I will discuss. I think I will get it.
So when we talk about max or min of a function, we're talking about the y values. When we are asked where the minimum is, then we want to find x. But when we talk about max or min, we talk about of a function, we talk about y values. Where the minimum is at pi/8. Where is the maximum? At -pi/8 and at 3pi/8, the same maximum, which is 2 in this case.
Mhm.
Yes, please.
I was just asking if you're going to give us a graph on the test.
Okay.
To find
So
the
let's-
maximum.
Okay, let's move on. Oh, well, we already said that. Okay, so let's talk about a little bit about chapter 6. So chapter 6 deals with exponential and log, right? Okay, are we in the clear with the exponential and log? Any questions? Exponential decay, exponential growth, condensing, expanding, log equations, exponential equations, okay?
Growth and decay.
Okay. Yes, of course. Yes, that's why I want to review everything. Yes, so which type of problem you would like to start with?
What do you have first?
So, exponential decay, exponential growth, solving exponential equations, solving log equations, condensing and expanding.
Whichever is coming in the test.
Exponential.
Exponential what? Decay?
No, solving exponential equations.
Solving exponential equations. Let's start with that. So one example that I would like us to review, sorry. Okay, so is for example this. 7 raised to x plus 2 equals 5 raised to 2x minus 3. This is an exponential equation. And in order to solve for x, we need to apply log. We cannot change 7 and 5 into the same base. We know that. So this is x plus 2 times natural log 7 equals 2x minus 3 times natural log 5. The next step would be to distribute. X natural log 7 plus 2 natural log 7 equals 2x natural log 5 minus 3 natural log 5. And of course, I'm going to move this here and factor out x. We've seen this before, but I would like you to review it for the test. Of course, if you want to check, you will plug it in and then check. Any questions about this? You should be okay because we've seen this before, right? Is this okay? Yes? Okay.
So I have a
Yes, please.
general
Yes.
question.
Yes.
In which scenario we have to find domain first?
Yes, when we solve logarithmic equations. Very good question. So let's solve a log equation right now. So with the exponential equations, as you know, exponential function is defined everywhere. So there is no reason for domain. But for the log function, it's a different story. So I'm going to just make one up. Log base 3 of x plus 1 minus log base 3 of 2x equals 7. So I recommend, it's not mandatory for you to say the domain here, but I recommend state the domain because if you forget to go back and check, then you're not going to get full credit. So I think it's easier, but it's up to you. So this says greater than -1 and this one greater than 0. So of course the domain will be 0 to infinity. So when I am done with this equation, if I don't, if the solution is not a number that is positive, then I will have to disregard it, right? Okay, so now I have to remember how to condense this. How do we condense it?
The product
Careful.
or not, we're doing it.
Yes, so this is log base 3 of x plus 1 over 2x equals 7. And from here, I will change this into an exponential equation. So let's change it into an exponential equation. How do we change it into an exponential equation?
About 7.
Yes, 3 to the power 7 equals x plus 1 over 2x. And all we do is just cross multiply. So So 2187 times 2, how much is that? I got 4374. X equals x plus 1, or 4373 x equals 1, or x equals 1 over 4373. As long as it's a number greater than 0, this works.
So you times 2x by 3 is 570.
Cross multiplied. Yeah. Okay. Let's look at an exponential growth and decay. The models will be given to you, of course. Any questions on this? I'm looking at the chapter 6 review. Are we okay with condensing and expanding?
Yes.
Is that a yes? Yes, okay. Not enough problems here. So let's suppose we have a radioactive substance whose half-life is how many days you would like? Half-life of a radioactive substance. Let's say 100 days. We're just making up a problem. Every time we talk about a half-life and a radioactive substance, and the model will be written, it is written in the test, on the test for you. This is m of t equals m0 e to negative kt. This is the model for a radioactive substance that decreases its mass in time. So every 100 days, whatever we have, it decreases its mass to half. Okay, so is there something, I do not have the initial amount. I don't know how many grams or milligrams of the radioactive substance we have. But is there a way of determining the radioactive decay knowing this? Yes, and how? So this is basically giving us a point. Can anyone give us the point?
Wait, so
50. 0.5 and 50.
So you mean m0 over 2, comma,
100?
very good, excellent. So we start with whatever amount, m0. In 100 days or 100 days later, we have m0 over 2. Is that point clear to everyone?
Yeah, because M0 is the initial.
The initial value,
Half of
the initial amount, yes, or mass.
Divided by 2.
Exactly, excellent. Do we agree with the point? Yes? Good, so now please put the point in the model and tell me what to write. Is it okay? Everyone, yes, please, help.
So, 100 equals M0 over 2.
I got carried away. Sorry about that.
So,
Got carried away. We have to be careful. Time is independent. Time does not depend on anything. Okay, now we're ready. I realized it was wrong when I started putting it in. Okay, so then,
50 equals
not 50, not 50. We're putting the point in. So let's put the point in here. Yes, m0 over 2 equals? Equals? Yes? Yes? Very good. That's it. Excellent. Is that clear? Is that clear how we put the point in? Okay, what we've done this before, so I just wanted to review it with you. So then what? What happens next? Look at the equation.
100 over 2 and m0 will be cancelled.
Yes, m0 goes away. So then the left-hand side is 0.5 e to negative 100k, and what happens next?
natural.
Excellent. So natural log. So natural log 0.5 equals negative 100k, so k equals negative natural log 0.5 over 100. Tell me what you get, and I'll look at it and calculate this side, the 0.5, okay, and divide by 100, and that is yes, and we should, yes, please, when you determine this, please use 4 decimal digits.
0.0069.
Yes, yes. So now we go back and put it in the model. So now we know that m of t equals m0 e to negative 0.0069 t. Okay, so here's my next question. So we have k. K is 0.0069. So I have the model now. Okay, so how many days will this radioactive substance need to decay to 50% of the initial mass? We don't need to calculate that. The answer is 100. We don't need to calculate, right? We know the half-life. Okay, so here's another question then. How many days will this radioactive substance need to decay to 10% of the initial value? What will that mean? And what is the point that we have to create now? How many days till it gets to be 10% of the initial value or initial mass? I don't know. but this is 0.10 times m0. So let's write m 0.10 m0 equals m0 e to negative 0.0069 t. And we will find out how many days are required or needed for the radioactive substance to decrease its mass from whatever to 10% of it. Again, we will simplify. We will apply natural log, and we will get T. Do you think that this will be somewhere between 0 and 100 days or more than 100 days? Of course, because it needs 100 days to come down to 50%. Awesome, well done, good. So all I have is natural log of 0.1. Doesn't work. Okay, natural log 0.1, and if divide by the previous answer. Bless you. Divide by the previous answer because it's going to take the whole thing. But I did not change the negative here, so I'm just gonna put 0.0069. Oh, it was negative actually. That's good. Yeah. So when I calculated, I did not put the negative. But it's even better now because I have what I need. Okay, 332.19. Can anyone confirm this? Because I kind of changed numbers in here. Is that what you get? Did anyone get 332.19? Yes? No? Okay, I'll assume that that's correct.
Yeah, sorry, yeah.
Thank you very much. 332.19 days. Anything else about maybe graphing exponential, graphing log? Any questions other than what we just looked at? Yes. Say it again. I don't know who was first. Yes.
Can we go over them?
I don't know what of them means. So,
What you just said.
okay. Imran?
So we have a negative sign in the formula, right?
Yes.
And our k is also negative, so it will be positive then.
Or no, but natural log is negative. Natural log of 0.1. Very good question. Look at the graph. Look at the graph of natural log. Here it is. This is 1. This is 0.1. Look at the value. The value of the numerator is a negative number. A negative number divided by a negative number has to be positive.
Yeah, I'm talking about the
Oh.
initial formula for this. Like whatever is given, like formula. Is it
So K is 0.00969.
it's a positive number?
Yeah, K is a positive number.
Okay, and then
Because this is negative, and you have a negative. So when you determine natural log of 0.5, this will be a negative number times a negative number, you get a positive number. But yes, the model has minus in front. However, it's a very good question. In some books, they do consider positive. They consider positive in front of K, and they say that K is negative.
negative general.
I'm not so sure about that, but some books do present that model with positive, and they consider that K is negative.
Because if we have the decay model, then the k should be negative in all cases.
Not necessarily, depending on how you present the model, but I understand what you're saying.
So then if we put
If the
that
model
negative-
has a minus in front and you consider K to be positive, it's still going to be a decay. If you consider plus in front of the model and your decay rate is negative, it's still going to be a decay. It's the same thing.
Oh.
So I'm saying this. Very good question. So if you write the model as m of t equals m0 e to kt, then you will consider k negative. If you write m of t equals m0 e to negative kt, then you will consider k positive. Either way, it's going to be a decreasing function, no matter what. So if you consider k negative, this is a decreasing function. If you consider k positive and have a minus in front, it will still be a decreasing function on all its domains. It doesn't matter. Yes?
So for t, I didn't get that number.
I could have made a mistake. That's why I needed one. We forgot to put parentheses around the denominator. So we always have to put parentheses around numerator denominators, otherwise the calculator will not perform the operation you wanted it to perform. So what we see here is one thing, and when you punch it in the calculator is a different thing.
I still have the same thing.
Let me see.
Was it because you used?
Oh, yeah, so it's the same thing, but you're truncating and I'm not. I'm using the previous answer, the whole thing. The difference is that one, oh, I see. No. So with the calculator, I did not use just this. I used the previous answer, and that's why it gave me a little bit of different number. But that's okay. A difference of one, it's fine. Yes, next question. Yes, Bailey?
So, are we gonna have to graph exponential log function?
Yes, that's my next step.
Oh, okay.
Okay, so what would we like us to graph? Exponential, we would like to graph log. Both? Fine. Let's do both.